and basically handling all the complex logic and all the layers via which we are serving the data, right, to the client. That is a browser in our case, or we can have a mobile applications or any sort of, you can say, other front end layer which is coming into the picture, right? So this is a fair enough definition of backend developer. Like what backend basically do is handling the request from the client. That is, a request is coming, and that could be a multiple request or a single request. And whenever the request is coming to a server, so the backend is like, you can say, uh, accept the request, and we have a certain steps on the basis of we can decrypt the request, authenticate the request, and there's a chaining flow via which we just basically serve the response to the client from which the request was initiated, right? So that is all the definition of a backend developer, who is a backend developer, right? Now we are coming, whenever we are coming into the picture, like we are starting a journey of a backend developer. So what are the prerequisites we are required to become a backend developer? So first of all, we should be familiar with the some of the basic technologies which are running in the market, like you can say DNS, you can say domain name server, and we have sometimes the protocols which are using in the website, like the HTTP protocols, that is itself called the hypertext transfer protocol, right? So, and other one is the you need to being familiar with the client layer. What is client layer? From where the request is being initiated, like in a browser, if you are typing URL like www.google.com, right? So whenever you are hitting that URL, so first of all, that google.com is being converted, or you can say is getting an IP address itself. That is a DNS. That's why I said it is a domain name server, which is resolved into IP address. That IP address is mapped to a, you can say, a server from where being the request is being served later on, right? So this is the first prerequisite. We need to know about the certain parameters or certain, you can say, the uh, terms which is being used in the front end layer or the web layer, www dot layer, right? After that, we are coming to the certain things which are the concepts or the basic concept which are next level required to become a proficient, or the, you can say, a good backend developer. So one is the programming language. You are required to do the code in the backend. It could be a, I'll be covering those things later on one by one. But first of all, we'll just brush up these things. What are the prerequisites we require? So we'll be in this presentation. We'll be focusing on the certain areas which I am wrote down here. So one is the programming language which we require to write down the code. Then you should have a fair enough knowledge of the data structures and algorithms which we are basically using to write down the complex logic or building up the algorithm on building up the logic on the basis of existing algorithms, or if there is not an existing algorithm, we have to create our own algorithms on the basis of existing algorithms which are existing in the market, or which we have to have, right? Now we have certain frameworks, sorry, we have certain frameworks on top of those we'll be working on, because these frameworks are basically the predefined layers, and their certain format, or you can say architecture, is predefined in these frameworks, so that it is you don't have to work on the plain layer, or the, you can say, the uh, on the basic layer, right? So in that case we require the frameworks, right? Now the next set, whenever a request is coming from a client, then we need to interact with the data, right? So because we can't save all the data at the client layer or the server layer, we require some kind of sort of mechanism where we can store the data, and we can serve the data to the client from there itself. And that is the persistent layer where data is being stored in the disk itself. Whenever the request is coming, we'll be pull down the data from the database and will serve to the client, right? Then it comes to the manual deployment strategy. Once a code is being written, algorithms is made up, and on the basis of those algorithms we have wrote down the code. We have fitted down all the things according to the framework. We have added the SQL or the NoSQL queries from their data is being pulled out, right? On the basis of these, we have some kind of deployment strategies uh, which will be required to deploy our whole code, so that whenever a request is being coming out, we'll start that we'll pointing out the request to that you can say our application or the process which is running out, and serve the data from there. Then we have some kind of services which we required into the uh, backend. Whenever you are starting your journey, there is a monolithic services. So whenever we are requiring or we are building a complex you can say applications, so we do have multiple parts over there. But initially whenever we are starting any application, so we just write down all the code at a single place, so that we don't have to go at the different locations to make the things complex. So initially we made this things very simple, then later on we move to the different things to make the things strategically, or you can say fix accordingly as the traffic and the certain things grow in into our system, right? Then we come up to the authentication strategies. Whenever a client is shooting a request to us, so we need to authenticate those requests on certain mechanisms that I'll be covering later on. Like in case I'll just mentioning out, whenever you are logging in a website, you just need to enter the username or password. So you have to authenticate, the server is being authenticated you on the basis of these ID passwords. How we'll be covering later, right? Then I just told about the HTTP is the prerequisite requirement, and the one is the DNS is the domain name server. How the domain is being mapped to your IP address, you know, right? Next one is these are the basic concepts which are required to become a backend developer, but there are certain advanced concepts which are also required later on the journey to become more proficient and to make you comfortable in the market right now is going on in the right. So you need to work also upon the some kind of distributed mechanism, right? And in that part we do have a caching, we do have a queuing mechanism, we do have CI/CD pipelines for automating the deployment process. We do have a searching strategies to make a search and complex search so easy to like do. And we do have a distributed DB architecture where we do have a some kind of master slave architecture where one node is not working so that other node could serve the data to the users, right? And we do have a distributed tracing here over there where we do have a whenever a request is coming and we do have a multiple hops, so we could just track a request and response from where the request is being initiated and how much request has been coming to a server, and where the lagging behind what kind of data and drop is being over there, right? Now, next is the CDN, that's the content delivery network, you can say, where whenever we are serving any content, so every time we cannot push that request to the directly server so that we can reduce the load on the server. So, whenever you are opening a website, so there is an HTML layer, right, where the HTML or the static content is being served first of all from the nearest CDN, and one of the CDN is Akamai. Hope you heard about. No, if you're not, then it's fine. We can cover it later, right? There are certain other advanced level concepts which we can cover. One is the microservices that I told previously. We whenever we are building a software or project, so first of all we try to accommodate all the modules or the components in a single code base. Whenever we find like the code base or the logic is become so complex, so we just uh, uh, distribute those things on the multiple servers, and also we just break down our code into the multiple services, that is called the microservices, right? And we do have some kind of advanced authentication strategies where we will be using some advanced authentication mechanisms to basically for the security purpose to get kind of some kind of a rate limiting on our APIs whenever one is hitting our API. So we don't have to exploit the our system. So we do have certain kind of advanced authentication mechanism or strategy over there, right? Then it comes into the picture the serverless technologies where we are not deploying our code on our environment. We are deploying our the code in the serverless where we don't require a kind of proper server to share the request or the response, but we do have a serverless architecture where some kind of cloud provider is managing our code. Just we are just deploying the code on their servers, and they are responsible to provide us the infra from which the code is being running on, and from there where the request will be served over there, right? Later on we do have a version control system in the system. Whenever a big team is working on some project, so we do have multiple guys and we do have multiple people who are working on the same code base. So whenever we are writing a code, so we are just required to save our code like we are using our system here, right? So whenever we are writing something in notepad, right, and we just shut down the system, so might be if we have not saved our code textual things, it will be get lost, right? So in the same thing, you can understand whenever we are writing a code, right? So if we have saved the code locally, but we didn't have the push the code in the server, so the server, everyone in the team won't get that code at the same level, right? So we need to ensure that everyone is on the same page. So that's why we'll be using the version control system, and one of the best example of the version control system is the GitHub. Hope you everyone heard about the GitHub. So it is very popular in the market right now, right? Then we do have certain kinds of API architectural styles on the basis of whenever we are developing an API. So what kind of architecture style we are following on to develop the API. So we do have a RESTful APIs, we do have a SOAP APIs, we do have a gRPC architecture, we do have a some kind of GraphQL. So I'll be covering one by one, and if you will be required, then later on I'll be sharing some resources also so that you can dig dive on those things and cover these things, right? Then we do have an advanced level concept of API protocols. We do have AWS services on the basis of which we can make our development, deployment, and other things become faster. So, like whenever we are working on a piece, so previously when the cloud providers in the market were rarely, so we need to set up our own infra in the own premises, right? But from the last decade, it has been become so popular. We do have multiple cloud providers in the market, like the Google. We do have Azure, we do have AWS services. So on the help after coming these cloud providers into the picture, that development and the deployment process has become so smooth, right? And the costing is also become so smooth. Like if we have thinking like we are building a project and we don't have infra, so we have a kiosk like where to deploy all the things. Right now these things are out of our mind. We just need to buy the services from the cloud provider, and just we are just thinking about to deploy the things. And also these deployment is being taken care by their team also, if we don't have team for the deployment purpose as well, right? Then we do have a monitoring and alerting system as well, like how to monitor, like let's take an example. Like we have built all the system, like we have built the whole website, but we don't have a proper monitoring or the alerting, right? So how do we know like that website is always up or not, right? So on the basis of these things, we required better monitoring and better alerting system, so that whenever a website is being gone down, whenever an API is being gone down, so we get the proper alerts anywhere, whether via mail, via SMS, via pager duties, via any kind of WhatsApp messages, so that we are getting up to date over the monitoring and alerting of our system, right? You can compare this thing via, you can say, whenever we are at home and we just want to go, we just want to leave the home and just we want to monitor our house, so we just install the cameras, right? So that camera recording is being watched by us, so that no one is basically what is doing with our at home, and or with the kids who are present at home, right? So in the same thing, you can compare this thing, like whenever a server or the client is running, our website is running, so our website is always up, our all APIs are always up. So we need to add some kind of alerting mechanism on these APIs, so that we can uh, get some kind of alerts when these APIs or the system goes down, right? So this is all about here, right? Now, previously I mentioned there's a term called DNS, that is a domain name server. So domain name server is nothing, just it is a directory of domain name. And domain name, I just told, right, when we are typing www.google.com. So here www.google.com is a domain name that is a mapped or aligned with an IP address. So whenever we are typing it, it is going to our DNS provider and get the exact IP of that domain. And that IP, then again that IP is being installed, or then IP is being basically routed at our system. Then on the basis of that IP, we are serving the request and getting the response for the user or the client which initiated the request, right? Now, I just told about whenever we are jumping into a field of a backend developer, so we'll be requiring the programming language to do the coding. So we have a multiple variations of programming language in the market. So one is Java, other one is Python. We have a PHP also, Ruby is also, and JavaScript also. But whenever you are starting with your journey with a backend developer, so I'll recommend like JavaScript and PHP and Python are the easy things to start with. later on, if you are being familiar with these three, then you can go with the Java and Ruby also, right? Because Java is some kind of a mainly required prerequisite required, like the oops concept should be very well versed with. So sometimes people don't indulge or get involved themselves into the oops concept, so they get lost out in there also. So whenever you are going into a mode of becoming a backend developer, so you can start your journey with the JavaScript, and later on you can explore other variations of the programming language as well, right? Then we come into the data structures that I mentioned earlier. So there are certain kind of data structures, or you can say the in-memory data structures, which are required when you are doing code or building up the logic or the complex logic. So whenever you are fetching the data from the database, so you have to store those things into the in-memory at the code level. So where the data structures are required. So we do have a couple of data structures I mentioned over the screen. Like one is the array, linked list, other one is the stack, the hash tables, trees, heaps, graphs. All these data structures are required pretty much whenever you are required to cover, or you are going into a phase to do the coding. So you can explore each and every things, because these are at least required to do the code, because arrays, linked list, queues, stacks, trees are the mostly used, and heap is also mostly used. But whenever you are doing the you are building a complex logic, or you are building a, you can say, like a connection system, or you can say one connection and multiple connection system, so we'll be requiring graph or the trees as well, right? So you can explore these type of data structures whenever you are uh, uh, jumping into the backend developer field, right? Now, initially I mentioned like we'll be requiring some kind of frameworks. Frameworks is the basically you can say pre-baked things, and you can compare it with, like, you can we have a some kind of what I say, like whenever building a thing, so some there is a prerequisites to build up a API. So these frameworks are like basically covering all the prerequisites itself. Like whenever we are building a, you can say, API, so we'll be requiring a controller, service, DAO layer, you can say data access object layer. So this framework is ensuring like we are doing all the things in the same manner, rather than we are just breaking up the principle of making an API. So these are the you can say these are the uh, pre-built market frameworks which we can use, and we can like top of those we can use programming language, data structures, database over those to build up an API, right? So Spring is a framework with the help of Java. On the top of this we can use the programming language Java over the Spring. Flask or Django is the framework on top of which we can use Python. Laravel, Cake PHP, and Coding Nature is a framework when you are working on the PHP, so you can use these, or you can explore these frameworks whenever you are working with the JavaScript. So you can explore Express.js with the Node environment, right? And Ruby on Rails is the framework when if you are desired to work on the Ruby language, right? Now it comes into the picture database. So we have a I have categorized the database into four types here. But whenever you are starting a journey, so relational database is the first thing it comes into mind, because we don't want to make the things complex. So whenever we are building an API, so initially we'll be working with the MySQL, that is a relation database. Hope you have everyone about heard about it. We have a table structure. Each table has some columns, some rows, everything, right? So this is the bare enough thing. But whenever you are being familiar with the initial steps, then you can move to some document DB, that is the MongoDB. We have a time series DB, example is the InfluxDB. We have a key value DB, example is the DynamoDB or the Redis, you can say. So, and we do have many more here, but I have not mentioned here so that you won't get confused. So initially you can start your journey with the MySQL, then we can go one by one with the MongoDB, InfluxDB, DynamoDB, on the basis of the requirements you do have in your project or in your system, what you are building right now, right? Now we have some DB level advanced concepts. So whenever like we are building a system and we have become so much mature, and the data is increasing our tables day by day, so it is not it is pretty much not like being comfortable to serve the APIs within the desired limit, or like you can say desired limit is a 1 second whenever user is hitting an API over the website. So there's some loader is coming over there, right? So the loader is coming because a database or other resources is taking so much time to pull out the data from the desired resources, whether it is a cache, whether it is a database, or these things. So when the size of the database is growing day by day, so we have to opt these advanced level techniques on the database to serve the response as per the desired limit we have decided when our project or the traffic was not that much. So when the traffic is growing, so number of APIs hit is also growing in a server. So we have to suffer with the slowness of the system. So at that level, these advanced level things come into the picture, right? So one is the sharding. Sharding is a technique where we just divide a table into the multiple servers, right? So like there is a server 1, there is a server 2. So we just divide the whole table into the two parts on the basis of some key, whether you can say it is an auto increment ID. So we can say if the table has a 200 records, just example for the hypothesis purpose. So we just divided the table into two parts on the basis of the primary key or the auto increment ID, you can say. First, 1 to 100 rows, 1 to 100 rows are into the server 1, and next 101 to 200 200 rows into the other server, that is server 2, right? So in that way we applied the sharding on the auto increment ID, that is you can say on that level, right? So we have just separated our data into the two tables, two servers basically. So whenever the request is coming for a you can say itself the row number 101, so we'll be routing a request to server 2. Whenever a request is coming for a you can say second or the third row, so we'll be routing a request to server 1 because the data is present at server 1, not at the server 2. And that mechanism is also being handled in the first layer when how to like route the request, right? So that is a or more higher level concept, but will you can see cover it later, not right now, that's not the time for that, right? Otherwise you will be getting confused over that, right? So next is the thing which I just mentioned is the replication. So whenever we are building the complex systems, right? So we need to make sure like our data is being a data copied is also present somewhere, so that in any case our main source of data is you can say lost, so we can recover the data from there. So that's why we come to, it come into the picture replication. So replication is nothing else, just a simple terms you can say it is a copying of data into some other location from where we can access the data for some other work also, and also we can use the data in case that the main database is being lost out, or you can say crashed, a disk is being crashed, you can say, right? Now it comes into the picture indexing. So indexing is basically doing it to make our queries, or you can say make our queries respond more faster. If it is a table which has you can say 1 billion rows, right? And there is not an indexing present on a column where on which we are doing a query. So it will iterate each row one by one and find out the data. And let's assume that row is at the last level, like it is at the 1 billionth row. So it will take too much time to get the data or pull out the data from the database. So that's why we are requiring indexing, so that it could make some kind of strategies over the column and get the data as soon as possible on the basis of indexing strategy we have used over there, right? So we can also explore the indexing, sharding, replication. These are the advanced topics, but these are very much prerequisites whenever you are jumping into the field of backend developer, right? Now we are having a everyone might be heard about these two things, monolithic service, microservices. So whenever you are searching about the backend developer journey, so you will definitely heard about these two terms. So monolithic service and microservices, as I mentioned previously also, whenever building a service like itself, we can say we are building a e-commerce website. It has a two three modules. One is a search module, one has a category listing page, other one is the detail page, other one is the cart, other one is the checkout page, right? So initial level, when we don't know, we are not forecasting how much traffic will be serving in next a year or next span of 6 months. So we are building our code like don't make the things complex. So we are just putting all the things in a single place, so that the deployment process, release process, everything, you can say testing process, QA process, everything should be smooth. So we are doing, or we are just putting all the things in a single location. So that is a monolithic, right? Everything is being served from there. So it has some pros also, it has some cons also. Pros is like mm, all the data, all the code is present at a single location, or single, like you can say single code base. So we don't have to maintain the different code bases. Con is there, like if one type of, or you can say, if there is some failure in the whole code itself, and no one is able to get the request, other modules, card, checkout, category listing page is also not being served over there, right? So that's the con also. So I have just told you the high level pros and cons, but there's some other pros and cons as well as the monolithic service. Now we are coming into the microservices. So like whenever we are breaking the whole uh, uh, system into the multiple small services, right? And these services can be breaked up on the basis of certain factors, on the basis of modules, on the basis of business requirement, on the basis of you can say the traffic requirement, which traffic is being served more, or which type of users, or which type of you can say mm, you can say module is being served more, or which type of users are coming for which module more, right? So there are certain requirements, certain strategies we can use to divide the monolithic service into microservices. Or initially, at the initial level, if you are want to build up a architecture where you are from the scratch building a system from a microservice, so you have to thought through like what are the modules and what are the requirements you do have in your mind, and on the basis of those requirements you are breaking up your services into microservices. So this is all about the crux, like one is the whole single code base, and other is the, you can say, uh, we are breaking up the code base into different services on the basis of certain requirements we do have in the code base, or as per the business, right? Now whenever you are building an API is an application programming interface. So whenever you are visiting a website, right, and you hit like, let's take an example of Mintra. Whenever you are visiting Mintra, you are just showing number of you can say categories, or you can say number of you can say you browsed about the shoes. So you got the multiple shoes on a category page of the shoes, right? So those are being served via API, that a single API, like you can say www.mintra.com/get shoes is being get shoes is hit from there, and that request is interrupted, right, you know, and it is being coming at our end, at our server, and we just intercept the request, and we just find out this API is demanding shoes from us for that user on the basis of that search query request, like the size equal to 8, you can say, and we are just find out that request from the DB. Like we do have the proper database to serve this request. If we do have data, then we do serve the data to the into the response, and that the client is basically render that response over the web page, right? So that is whole about the API over there. So whenever we are building an API, so we have a different mechanisms. So majorly it is popular right now as a REST API is in the GraphQL right now. And SOAP is the user priorly over their time, but SOAP is a heavy system because it is XML based, not a JSON based, but REST API is the JSON based. And gRPC is a mechanism where we are using our system being more faster and all. Excuse me, just give me. Right, sorry. So gRPC is a mechanism where we are making our system more faster, API respond more faster. So it is majorly used into the inter-process communication whenever we have two microservices and those two microservices want to interchange the data. So we try to use the gRPC, but somewhere we also use with the client also, right? Now we come into the authentication strategies I mentioned. So whenever you are visiting a website, so first page you always come is a registration page or you have a login page. So whenever you are doing the registration, so you are providing some basic information that is being required by that website. On the basis of those things, we are generating some kind of token, and on the basis of that token, you are being authenticated on that website from the next time whenever then hitting a API, because in the API we are sending that authentication token. On the basis of that token you are being authenticated, right? So there are certain strategies which are present in the market. So pretty much most of the people right now are using JWT, that is a JSON Web Token strategy. Herein we are binding the token, right? We are sharing a token, and all the information of that token is present in the JSON format in the JSON, right? Like user details, you can say user ID, what type of user, user roles, and everything is present in the JSON packet over there, right? Other one is the auth mechanism, right? So we are using a auth strategy to basically authenticate the user. Next one is the basic HTTP strategy, where you are just sharing your user ID and the password in the headers, right, in the API headers, and we are authenticated user on the basis of those user ID and password to the user. Next is some kind of random API keys. Like we have to have a public key, we do have a private key, and in the API headers we are requesting some kind of key which is being served from the client, and we are decrypted those keys and find out these are the legitimate keys which is being sent out from the client which we contacted on previously. And on the basis of these things, we are doing the authentication. So you can read on these things in the, you can say, web, right? Now it comes into the picture distributed caching. But before distributed caching, we can cover up the caching part. Like what is caching? Caching is basically whenever a request is being served, or a request is coming, so first of all the request is interpreted at our server. So rather than to serve all the data from the DB itself to because when we are pushing all the calls to the DB, number of input output operations will be increasing, and that will suffer our server to not serve next set of requests, because it will take some time. So what do we want? Some kind of data which we can preserve in some kind of RAM, you can say. We have a memory, like we have a hard disk, then we have a SATA disk, we have a RAM, we have a L1 cache, L2 cache. So we can preserve the data into the RAM, so that we can, whenever request is coming, first of all we are checking into the RAM that data is present or not. If that is present in the RAM, then we are serving it. Otherwise, we'll go to the hard disk where the data is actually present. That is, you can say, DB layer, right? And now, how it is beneficial, because our APIs become so much fast if you are using caching. If you are not using caching, then it becomes difficult whenever the traffic is being increased or increasing day by day. So number of IO calls will be increasing, and your request being dropped out, and might be some of the users also facing uh, request timeout errors, right? So this is basically a caching part. Now we do have a queuing part also. So in the queuing part, we will be covering on, not going much detail, because otherwise you'll be getting confused. So for the queuing part, we can say whenever we are working on an event driven architecture, like we want to perform some things into the async or into the background thread, right? So we can use the queues where we can just push all our data, right? And that thing is being doing asyncly on a different thread. And whenever the you can say that operation or the request is being done, the data is being served from there itself. So we don't have to block the main thread to do that operation that we could do in the backend thread also. So we can drive those things from the queuing mechanism, right? Now I told like there's certain prerequisites, and we are doing a becoming a web developer. So AWS is also becoming a trend here right now, or you can say not AWS, some kind of cloud services. So cloud services, you can say whenever you are going for a deployment. So in AWS you require EC2. If you are want to store some things, you will be requiring S3 bucket. And if you will be going with the some kind of serverless technology, so you'll be requiring Lambda. So right, these kind of things you are pretty much required, or into the, if you want to fit yourself into the ecosystem of a backend. So AWS, Azure, or you can say GCP, Google Cloud, है ना, will be very much required for you to become, yes. So that's all from my side for the presentation today. So hope you will like about the presentation, and I think I some part I go deeper down, and we can also cover, right?
Yeah, so we have a couple of questions. So one of them is that someone has requested you to repeat the part where you explained sharding.
Okay, one second, one second. Sure, sure, sure. Yeah. So like I told. sharding is a mechanism, like sharding is a mechanism where whenever a data is becoming or a table size is being increased, right? So when the table size is being increased, and we are you can say putting all the data in a single location or the single server, and all the request is being served from there. So what we can do, if like we have a request is coming from two different locations, right? One is from, you can say, India, one is from Australia, right? So we can distribute our data of India and Australia into the two servers, one at the server present in the India at the Mumbai location, and one server we do have a Sydney location, right? So we have just distributed our data to two different locations. So whenever the request is coming from the Australia, right, so we directly go into that server nearby to that, that is an Australian server, that you can say DC at in the Sydney, and we find out data of Australia is present into the that server, and we can search from there itself, right? And whenever the request of India is coming, so we can search from here. Otherwise, priorly all the data is present in the Indian server, right? And if the request is coming from that zone, so first of all, that is taking a time to make a connection, and after that also all the data is present in a single location. So we are doing a computation in a single table to find out the data from that table. So that's why we just split it out the data into two parts. That is called the sharding. Hope I answered your question.
Uh, okay. Yes. So I think Ishwar had asked this question. Uh, I think it's answered. So he says thank you to you.
Thank you very much. Yeah.
Yeah. So there is okay. There are a few questions. Do you have any free course with a certificate? No, this webinar does not come with a free course or anything. However, you can visit Shiksha Online's website and go
Yes,
through
yes.
the backend development courses over there. Uh, what is Nupur is asking, what is the basic job requirements? I think the question is a little unclear, but maybe Nupur is asking that what are the basic requirements that you or the skills that you should have when you are looking for a job in this sector or
So
in this particular.
basically, yeah, what I mentioned, like if you do have a if you do have a knowledge of programming language, DSA, study about databases and kind of HTTP, DNS, basic authentication strategies, some kind of caching, queuing. So you'll be pretty in a situation of out of a scale of 10 of you have a rate of a 6 or 7, and you'll be definitely get a job on the basis of these things if you are good in these skills, right? Yeah, yeah.
Yeah. Okay, so the next question is a little specific to this person. So Shweta is asking that she has completed her MSc in microbiology,
Mhm.
and post graduation she has an 8 year gap and she wants to switch her career into IT. So is there any advice for her if you have?
Hey Rahul, I have completed my MSc microbiology concentration. Yeah, you can definitely switch. You can, if you have an interest in, you can say computers and all the things like. So you can definitely buy some kind of a course where you can just learn about some programming languages first of all, and you can after that you also before programming language you have to develop your interest into the data structures part, right? Because whenever you are doing a programming, so you have to deal with the data structures like the array, queues, stack, linked list, all the things like. So first of all, you have to run like you can read on some articles over there in the net and develop your interest on these things. If you are understanding those things, uh, you can easily. If you are not getting, you are not understanding those things so easily, then you can read these articles 2 3 times. So might be you'll be getting some kind of interest later on, and then after that you can buy some course, so free courses on the YouTube. Then I'll be sharing the link over here, right? Then after that, if you are comfortable with both these things, then you can uh, basically become a on a journey to become a developer or software developer. Then the things will be easy for you, and you can start exploring some more things which are more courses where on the basis of which you can get the jobs also. And
Okay,
those
one
and the fee
last
structure
sorry.
and the fee structure is not that much there, because initial at the initial level you don't need to buy the paid courses, right? There are a couple of free courses present on the YouTube as well. So first of all, you have to generate a habit of developing your interest. Once your interest is being developed, then you can go for the paid courses.
Okay, there is one more question that I wanted to take up, which is there on the YouTube live chat.
Okay.
How to choose between SQL or non-SQL database? What should be the parameters?
That is all about your requirement, like what kind of data is you are want to uh, push into the DB, right? Like example, we can take an example like if I do have a pre-required thing or prerequisite thing, like if I have a profile and those profile only have right now 5 fields, but later on the fields are increasing day by day, and I don't know so many fields are coming and how these fields are interlinking with the other things, then I don't know, then I can just first of all use the document DB, you can say MongoDB, and push the data into there, because structure is changing day by day, right? Once if I'll get a proper visibility, like we can say, take an example of job here. We have a recruiter, we have a job, we have to have a company, we do have a profile, so we do have a proper visibility, like how many fields are there into the job, how many fields are there into the company. So we are using here MySQL as well for this purpose. But for the other purpose, like where we don't have clarity, like we want to for the analysis purpose, we just pushing the data into the some kind of a document DB, right? And we just want to do the searching over there. So we just creating a flat structure over there, and for that purpose, we are using the document DB, or you can say NoSQL DB, where we don't have a clear enough requirement how complex and how interlinking of data is there in the system, right?
Okay.
Yeah. Yeah,
Next
Nihar.
question is okay, there was one interesting question. May I know the best free platforms for reading Spring Boot framework?
Itself a single, I'll just share the link here. Yeah, you can go to the Spring Boot website directly. I have just shared the link in the Zoom chat.
Okay. Okay, we have uh, one or two few more questions, but I think in the interest of time, we won't be able to take it.
Okay, fine.
Uh, Thank you so much, guys, for being so interactive and asking your questions. So, I was also asked that if you guys can have this particular presentation somewhere. So this is the YouTube link that I've shared on the chat. You can just
Mhm.
revisit the presentation, revisit the webinar because the recording will be on this link.
Sure, sure, sure.
Also, I'm quickly going to share a feedback poll with you guys. Just let us know if you found the session useful and if you would, recommend it to your friends. So this is just for understanding whether you guys like the session or not, and if we can have more such topics in future. So yeah, thank you so much. There are some responses here. Um, Last but not the least, Rahul, thank you so much for coming on board and sharing your insights, taking out the time for this. And we already have some positive comments in the chat as well. So I'm pretty sure that people actually quite benefited
Sure, sure, sure. No
out of
issues,
this.
Niharika. Thank you very much. Even I liked it. Hope to cover
Chalo,
more
that's
sessions
good.
in the future.
Uh, yeah, yeah. Yeah. Okay,
Sure,
I'm
sure,
just quickly ending the poll here also.
sure, sure, sure.
All right. So closing the session. Thank you
Yeah.
once again, Rahul.
Thank you. No issues, Niharika. Thank you. Thank you, audience. Yeah.
All right. Bye.